Hello everyone, welcome to today's lesson on scale factors. Alright, so in this lesson, or in this unit here, we'll learn about how we can enlarge and reduce shapes so that we can essentially change its size. Alright, so starting off, well, let's look at some grids here. Alright, whenever we have a scale factor, well, we're essentially just multiplying our length by that number. So, for scale factor of 2, our original shape here has a height of 4. We got a space of 1 here. Right, so now, when we want to scale it by a factor of 2, we're just multiplying all the measurements by 2. So instead of the length being 4 tall, it's now 8 tall. So 1, 2, 3, 4, 5, 6, 7, 8. Oops. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is just 4 multiplied by 2. Right? And of course, every single measurement applies. Right? After that, we're going to go at the bottom. We have a space of 1 at the bottom. So now instead we got a space of 2. Right, multiplied by that 2. And then we go up by 2. So our new thing will go up by 4. Right? And then here, we connect to the line that is 2 down and 1 to the right. Or 1 to the, okay, I'm kind of working backwards here. We go down by 2 and then move over by 1. So instead, we go down by 4, move over by 2. So this connects to here. Right. This gap here was 1 in the original photo. So right here, it's also multiplied by 2. Alright, so this applies to every single measurement on the shape. Alright, so we can see here 1 on top, so it's 2. Same idea. Nope. There you go, just like that. Okay, of course, decimals, still same idea. Right, we just have to try our best to convert it into the graph. So right here, this is 2 spaces, and this space is 1 space. So our new one, that'll be 5 spaces. Alright, so 2 times 2.5. And then here, it's gonna be 2.5 spaces. That's 1 times 2.5. Alright, and then we just continue on this shape. So it's around here-ish. And then we go 5 spaces up there again. So 1, 2, 3, 4, 5. 2.5 down here. 2.5. Yeah, just like that. And so every single measurement is multiplied by the same length. Right, so as you can, of course, imagine, we can go backwards too, right? We can get smaller. So here, we got measurement of 4. 4 here, and then 2 here. Right, and this diagonal here, it cuts across 4 squares. Right, so everything times 0.5 is the same thing as dividing everything by 2. Right, 4 times 0.5, same thing as just 4 times 1 over 2, right, divided by 2. So that's 2 here. That's 2 here. Right here, the original measurement is 2. Half this 1. Right, here we're going diagonally by 4. And of course, halved, it's going up by 2. Right, just like that. Of course, we can do it by quarter as well. Or not by a quarter, by a third. 6 tall, 2 wide. Alright, 6 times 1 over 3 is just 2. Alright, 6 times 1 over 3, that's just 2. 2 times 1 over 3 is 2 over 3, so it's only a little bit like this. Right, so it's almost a full square, but not quite. So it's gonna look like that. Right, so each of those is here is 2 over 3, just below one full grid. Right, so that's how scale factors work. Right, and we probably noticed something here, right? If it is bigger than 1, the image got bigger. We call that enlargement. If it's smaller than 1, the image got smaller, which is we would call it a reduction. Right, and also something to note that it's always positive. Right, we cannot have a negative scale. So it'll always be positive. Okay, and from here you can kind of imagine that this is how we can find scale factors. It's pretty much just the image, so the thing that got scaled, divided by the actual image, or the actual thing. Right? So in other words, the length of the new thing divided by the length on the original thing. Right? Because right here, this here is a length of 8, whereas this here is a length of 4. So the scale factor is the new thing divided over the old thing, right? So 8 divided by 4, which is 2. Right? Scale factor of 2. Right? So we can see this in practice here, right? What's the scale factor between the two shapes? Right, so once again, scale is the image divided by the original, or the actual thing. Right, so you can see here, to go from the original object to the new image, right, we underwent a reduction. Right, because the number got smaller. So the scale factor has to be smaller than 1. And we can see there that the original is 15.6. We divide that over the actual, oh sorry, not the original, the image is 15.6. Divide that by the original, which is 62.4. We got 1 over 4. Right, and that's it. So now once we have the scale factor, right, we can kind of guess what is the length of all the other sides. Right, again, the scale is image over the actual. So in other words, so now we know 1 over 4 equals to the measurement of the image over the actual. And now we're telling, or we're given that AB here is 10 centimeters. We want to know what's EF. Right, so we know that they're the same side. Right, 10, AB and EF, that's referring to the same side. So the 10 is experiencing this reduction of 1 over 4. Right, and we can see this algebraically. We know our image here is have our unknown, which is E over F. And then the original, right, we're given 10 centimeters. So 10. Okay, and then from there we just solve for EF. That's our variable. Okay, so we always give her the fractions because we don't want to work with them. Right, the lowest common multiple here is 20 between 4 and 10. So 4 gets reduced ahead to 1 over 5, or 1 and 5. 10 gets reduced to 1 and 2. So 2 times EF. Of course, from there we just divide both sides by 2. 5 over 2. Oh, of course, centimeters. Right, which makes sense, right? We can always kind of check our logic here. We know this EF here is a reduction of 10. So this has to be a smaller number than 10. If the scale factor were 2.7, what's EF? Right, exact same idea. So 2.7 is EF times 10. Alright, we don't like decimals, we don't like fractions, get rid of them. Alright, lowest common multiple is 10 here. So 10 times 10 gets cancelled out. 2.7 times 10 is just 27. Oh, that's it. Oh, I should not forget we have a centimeters here. Okay, that's it. Alright, so here's an exercise that you can try. Right, to draw this gingerbread man to make it smaller or bigger. Right, so copy the exact shape here. I can take an example. Let's take this middle shape here. So there's a little bow here. We got a dot here. We got little. Oh, that's in the wrong square, isn't it? Right, and then yeah, that's it for that square. And then let's do the square below. We got a button here, squiggle, and a little V shape down here. Here, a little squiggle and a V shape. Right, of course we can put enlarge that as well. So there's a bow tie around here somewhere. Down here, little V shapes here, a squiggle, V shape, right? So yeah, just kind of have some fun with that. That's kind of how we use scale factors in like a picture. But the point of the lesson is, right, the main thing I want to know is this is our equation we'll be using for the rest of this chapter or this unit. Right, so the scale factor is the new image divided by the old image, the new thing over the old thing. Right, so if this right here is our new shape, everything here will be is in a fraction over everything there. Alright, that's all. Good luck practicing.